Okay, we are live. Okay.
Perfect.
Yep, you are good to go.
Perfect. So good afternoon, morning, everyone. I will share my screen and we can start. Give me just a second. So can you see my screen?
Yep.
Perfect. Cool. So today we're going to talk about Naryo, right? Naryo is, in a sense, a multi-chain event processor, right? Let's go step by step. First of all, your speakers today, we are Mario Francia, blockchain engineer, and myself, I am Alejandro Dovale, head of R&D at ioBuilders. ioBuilders is a leading provider of digital asset solutions for cash and securities, mostly. And the Naryo project that we will be discussing here today is actually something that we use in our projects and with our clients, right? So let's deep dive on this. So Naryo is well, first of all, it's an open source project, a lab within the Linux Foundation Decentralized Trust, and in a sense, it's a framework for capturing and broadcasting events across multiple DLT networks, right? So what that means is, by framework, I mean so a little bit more complex and sophisticated than a library, right? So it has a specific semantics and domain that can be extended, right? And capturing and broadcasting events, I mean listening, for example, to Solidity smart contract events or changes for example, new blocks in a blockchain, right? So those kind of notification or changes in a network. And when I say across multiple DLTs, literally the project, the solution is compatible with several protocols, right? And the idea is to extend it as much to support as much protocols as possible, right? And so what's the problem that Naryo solves, right? So in a sense, it's handling the events, right? So as simple as that. So if you are a dApp builder, you probably will have to face this integration where you have to catch, for example, a Solidity event. You have to be notified on a specific microservice of a change in the state of a smart contract or a new transaction, right? That business logic is pretty common, and doing that in a resilient, production ready way and scalable and maintainable in the long term is challenging, right? And it's challenging because you will face probably or have faced things like no connection issues. You have to implement the business logic to retry when a WebSocket suddenly dies, right? Or you receive duplicated events or even miss some of the events that are emitted by a smart contract, right? All that pain, to say so, is pretty common. And things get even more fun and more complex when you are in a multi-chain or cross-chain environment, right? So because you have to deal with different stacks, with different complexities and nuances of different DLT protocols, right? And this is, as I was saying in the beginning, pretty common. I would say, in my opinion, that the majority, if not all, of the dApps out there somehow listened to events from a DLT network, right? And if that's true, we are talking about, there are more than 200 active blockchains. Only last year, like more than 5,000 dApps were launched, right? So all these people and projects probably will face the exact same problem, right? The same pains of handling these events in a production, resilient way. If we think about a little bit on the cost, the money behind all of that, it's implemented the business logic to do that probably would easily fall within, I don't know, 10% of the effort of building a dApp, right? doing a safe estimate. And if we take a simple number of how much money was spent globally last year in the industry, right, building solutions, right, we're talking about millions of dollars probably, dedicated to that simple repetitive problem that everyone have to face. So that duplicated effort and that integration cost, I mean, there has to be a better way to do it, right? And that's the idea behind Naryo. So giving a solution to this. So let's see how does it work. Again, it's pretty simple. Naryo essentially is a backend, right? That the user, an application, for example, will configure. That configuration, in a sense, will be the connection parameters to the node, like the URL to RPC endpoint, for example, the event parameter that have to be filtered, signature, etc., depending on the protocol that you're using, and the destination of where that events should be delivered, right? So that could be an HTTP endpoint, a database, it could be a queue, right, a RabbitMQ. So once Naryo is configured, right, with those three parameter sets, it will do its magic and will be in charge of handling all the business logic to retry if the connection fails, getting the event, connecting to the nodes, sending the event based on the filters configured, and broadcasting that to as many listeners or recipients have been configured, right? And that's it, simply, right? It's again, it's the idea behind Naryo is to give a easy to use solution. So some more features that I want to mention. This configuration that I just mentioned before, it could be static or it could be dynamic. So you can just deploy Naryo with and configure a YAML file and say all these parameters there, or you can use a dynamic configuration, by sending requests to an API, to a REST API that Naryo exposes. So you can, on real time, you can change what Naryo is doing, right? And in terms of what networks are supported right now, in this version, the actual version that Naryo is out there, it supports EVM compatible networks. So Ethereum basically, or in general, Ethereum compatible networks, and Hedera, right? And by Hedera, I mean the mirror node REST API that is used to listen to changes in even smart contract events or other changes in the Hedera network. Hedera, for if you're not familiar with it, is a public network that the technology behind Hedera is Hyro, which is another project within the Linux Foundation Decentralized Trust, right? So those two networks are supported right now by Naryo, and we have the plan to continue, supporting more and more DLT protocols on the project. And when it comes to, where are those events delivered? There are basically three main categories of recipients that are supported right now. And on the one hand, we have the queues, right, like RabbitMQ or Kafka, databases, PostgreSQL and MongoDB, where the events are stored, as simple as that. And then HTTP endpoints in general. So you can configure a backend. So you can configure a connection in Naryo to a backend server, and Naryo will send through a post request, if I'm not mistaken, will send the event data there once it catches. All of this happened, by the way, in real time, right? So Naryo is continuously listening to changes on the DLT network and continuously broadcasting to the recipients. So that's Naryo in a nutshell, right? So now my colleague Mario will do a demo. So Mario, if you want to go ahead.
Yes. Okay, let me share my screen. I think Alejandro, you have to stop share your screen because I can't. Okay. Okay, can you see my screen right now? No. Yes.
I cannot.
A second.
Yes, now I can. Sorry.
Okay, right now you can? Okay, awesome. So basically, what we are going to do here is to capture a process and process an event with Naryo. So for that, we need, first of all, a Naryo instance or a Naryo application. We are going to call it test Naryo in our demo project. Secondly, we have a DLT where we are going to be listening the events. Right now, we are going to use a Besu node with ERC20 deployed on the DLT. And finally, we are going to use a listener. For this example, we are going to use a HTTP endpoint, and we are going to call it Naryo listener. So the demo is going to be very quickly and very easy to understand. So basically, the flow is the ERC20 smart contract is going to emit an event into the Besu DLT. Naryo is going to capture the event. So Naryo is going to be listening the events in the Besu DLT, and is going to process the event and is going to send the event to the listener. So this is basically the flow. So here, what you can see is, first of all, the ERC20. So this is basically a hard hat project. Nothing interesting here. The Naryo listener, this is the HTTP server. Very basic. It's a basic server. So it's going to be listening, or is going to receive the event and is going to post in the console log. Here we have the Besu project, so nothing interesting here. And Naryo. Naryo is our Superman, so it's going to be listening the events, process the events, and sending to the server, to the listener. So here we have 3 terminals. That one is the server, the listener. This is the Naryo, the application, and this is a basic hard hat console where we are going to execute a transfer. But the main thing here inside the Naryo application is the configuration. So first of all, as Alejandro mentioned, we have configured different kind of DLTs, let's say Ethereum DLT or Hedera, for example, in this case. In this case, we are going to use a Ethereum configuration. This is the port and so on. And regarding the broadcasting, we are going to set here the listener. As Alejandro mentioned, we can use a RabbitMQ or Kafka or whatever. But in this example, we are going to configure a HTTP server, the listener that I show you in the slide. Regarding the broadcasters, some important configurations. But for me, the most important is that one. So, for example, we can listen or we can send all, let's say, process or things that are happening in the blockchain. We can, for example, set blocks if we want to only send all block information, transactions, if we want to send all transaction events, contract events, or filter events. This is very important because, as Alejandro mentioned, we can configure different filters just in order to send specific information from the DLT to our listener. In this example, we have configured an event. It's a transfer event. This is the signature. We configure this event in the ERC20 that we have deployed. We have set here global. So basically, that means all transfer events is going to be sent to the listener. But we can, for example, set a contract, so a specific contract address, just in order to avoid listen all events from the DLT. So as I mentioned, this is the server, the hard hat console, and the Naryo application. So what we are going to do is to perform a transfer operation. we have deployed the ERC20 before, and we are going to transfer one amount to this account. So let me execute the transfer. And as you can see, the application is listening events and is receiving all events. But here we have the transfer event that we have performed here. So as you can see, Naryo is processing the events and is sending the events to the listener. So as you can see here, the transfer event was received, and also all events because we have configured global here. So if you want to replicate the demo, or if you want to know more about the configuration and so on, you can go to the project, to the GitHub project, and all information is here. This is the demo, the step that I follow in order to prepare the demo, just in case if you want to try by yourself. And regarding the configuration that I showed you, all information is here. As you can see, everything very easy to understand with emojis, tables, and so on. So yeah, basically is all from my side, Alejandro.
Perfect. Thank you very much, Mario. So maybe I can share my screen again. Give me 1 second. Oops. Okay. Sorry, I'm trying to find the correct tab. Where is it? Okay, so okay, so can you see my screen? Yes, perfect.
Yep.
So 1 second. Perfect. So, oops, this is the demonstration. Okay, so after the demo, so let's talk about a little bit of the history. So how did we get here, right? You know, around 2018, there was an open source project called Eventeum, which basically did, this same task that Naryo does, that Eventeum used to do it. Eventeum, as per description of its GitHub project, is a resilient Ethereum event listener, and which basically bridges the smart contract event with backend microservices. So it gets the listens to events on an Ethereum network and send that to another microservice that you have in your application. That idea is the same idea that Naryo does. It's just a little bit more. I mean, it is expanded to support more protocols and more than backend services that will listen to those events, right? We ioBuilders, we were using this project, but at some point it was not maintained anymore by the original developers. So we did our own fork around 2020, 2021. And our own fork, we personalized and customized some things. We added support for Hedera. We use that fork in our own, clients and projects and our own production deployments, right? And we kept, the project alive on this ioBuilders version. And then eventually we decided, we got a lot of changes, let's say, on the backlog for Eventeum. And then we say, okay, let's do this in a way that can be more easily distributed to the community. We also would like to onboard more people, and using an open source, approach. And that's where the Naryo project was born as a lab within the Linux Foundation Decentralized Trust. A lab is basically a project in the umbrella of the Linux Foundation Decentralized Trust, which is not, it doesn't have the let's say, the same requirements and guarantees of maintainability that an official project like Besu, for example, but the idea is to start as a lab, and who knows, where we could be in a few months or years, right? And yeah, so we have a roadmap ahead, and we would like to extend the protocol, extend the project to support more protocols. I don't know, Solana, Ripple, etc. We also want to support more broadcasting recipients, so more queues and etc. Right? And add accessory tooling like a front end for easier management of the configuration, or for easier monitoring of the Naryo backend that is deployed. Right? All this stuff is right now in the backlog. And we would love, of course, to have you on board. And I have the link later here to share with you of the project. And a bit more on the features that Naryo has. So first of all, Naryo, as I was saying, is open source, is self-hosted, so you don't depend on a third-party SaaS provider or something to use Naryo. So you just get it and deploy it on whatever infrastructure you have, like Kubernetes. So the idea of Naryo is to make it simple, lean, so you can easily integrate it in an existing application if you want, right? So there is no big deployment that you need or anything like that. So it's really a simple microservice, if you will. And then the interface as I was saying before, there's an interface so you can configure the filters. That configuration that Mario showed before, you can do that also through a REST API, and it's really straightforward to follow, I would say, well, in my opinion at least, to configure the different parameters of Naryo. Then there are 3 types of notification that you can get through Naryo, which are smart contract events, classic Solidity smart contract event, for example, transaction events, so you can get notified when a transaction is confirmed or is dropped, right, etc. And then you can also be notified of new blocks being issued on a network, etc. So those 3 kind of events are right now supported. Also, the project natively supports Spring Boot. As I was saying, Naryo, you deploy it as a backend, essentially, but the way to deploy that, you have to create a project that imports the library, essentially, and then that project, that backend is what you deploy. That there is a native support for Spring Boot. So just by doing adding 3 lines of code, you can have a Spring Boot project set up and with Naryo running, right? Then the processing of events, etc., is fully asynchronous. So you in that backend that I was mentioning before, you don't have to. It won't block the application. There will be a multi-thread approach to handling the different events, right? That's one of the things also that makes it resilient in when facing high volumes of transactions and events, etc. And well, as I was saying at the beginning, there is you can configure it dynamically, so you don't have to just rely on YAML files, right? Talking about the vision and ambition behind Naryo, the idea is, at some point in time, to have a one-stop solution for handling the events on any protocol that you need, any and all protocols that are out there, or the majority at least, and support natively the nuances of the different protocols, and support a wide variety of broadcaster and recipients, right? That one-stop solution to this task, that's what we want to do with Naryo. In that vision, the impact that we expect to have is facilitating, on the one hand, cross-chain interactions, right? So things, listening from one or from multiple DLT networks should be simple. So we expect that more application go cross-chain by using Naryo, ideally, right? And also, because Naryo and the main value that Naryo brings is making life easier for developers, right? So making life easier means less development cost. Developers do not need to repeat the business logic that for handling the events and so you can simply have faster innovation or development cycles, right? So that's and more importantly, you as a developer, you will focus on your application, your business logic, right? You focusing on this, I would say, pretty horizontal task of handling events and managing the read-write logic, etc. All of that will be handled by Naryo, so you can focus on your product and your features. Also, because it has been tested, at least by us, and used in production environments, in enterprise and financial institution environments, etc. So we expect that more solutions, enterprise solutions, would benefit from this. So it would accelerate the time to market for these enterprise solutions. Even though they could be mission critical operations, right? Naryo should be resilient enough to support, I don't know, handling transactions of transfer of money, of bonds between financial institutions, right? And guaranteeing that any changes or any event of those operations are properly delivered, right? So to the legacy or core systems of enterprise solutions, right? And in Naryo naturally fits in event-driven architectures. That's normally what the patterns that we use at ioBuilders, in fact. And what Naryo brings to this kind of architecture is a harmonization or standard way of handling the event. So you can have only one microservice or only one component that manages all these connections, all these all these interfaces with many external systems, and this component, which is Naryo, would communicate properly with any other microservices or components are in your event-driven architecture, right? So it should, as I was saying, make life easier for applications that use this specifically that use this kind of event-driven architecture, right? And I would say that, yeah, as I was mentioning a few minutes before, this is an open source project. We really would love to get your feedback. I will quickly go to the project here. So you can find it on the Linux Foundation Decentralized Trust Labs organization. And you can find here all the, more technical documentation, of course, if you need. There are 2 tutorials that I really encourage people to follow. One to use Naryo with Besu, like Mario just did, and one to use Naryo with Hedera, Hyro, right? If you want to contribute, feel free to just, open pull requests, open issues, etc. And at some point, hopefully in the near future, we plan to open a Discord channel in the Discord server of the Linux Foundation. So we want to really, give people the tools to contribute it, to give feedback, and to use it, right? So yeah, I think that's pretty much the meat and potatoes of today's meetup. So I would really pause here and love to know if there are any question, any comments from out there. Okay. Oops. Let me stop sharing the screen. Well, that was faster than I expected. Perfect. Thank you, Daniel. I hope this you find it useful. I will take a quick look at the YouTube live stream, just in case there's someone asking something there. No, nothing. Cool. Okay, so Daniel is asking any clients you have had with our previous implementation of the event system. So you mean that with our own fork that we had in run? Well, I mean, I could not say names, but we're all talking about financial institutions or FMIs. Yeah. Okay. So use cases. So I mean, Naryo is you can build many different use cases with this, right? Pretty common. Well, so let me answer your first question. So the majority we use Naryo in, I would say, 80% of our projects and ioBuilders. Those projects are mostly these digital asset solutions with financial institutions or NFTs, marketplaces, NFTs related tokenization ecosystems, right? Within those financial institutions that I'm mentioning, think about the FMIs, think about tier 1 banks, right? And we are talking about both, pilots and production solutions, right? On the other part of the spectrum, on the NFT tokenization side, we think about tokenization studios that tokenize, for example, collections of collectibles for brands in the comics space, right? And these firms normally what had to do were issuing tokens and doing airdrops, all that activity, right, which is normally would be high volume back in the day, would be handled by Naryo, right? So those are kind of the real world use cases that you can do with this. More recently, we had a client interested in doing a kind of indexer, right? So by indexer, I mean this. Well, you probably know what an indexer is, no? So it gets everything that happens in one blockchain and stores it somewhere else. But you can use Naryo for that too. And in that particular use case, the purpose behind that was to do a migration of a blockchain, right? So pretty much getting transaction of a smart contract, moving it to another network. So it's pretty, I would say, agnostic in terms of the use case that you want to use. If that answers your question, Daniel, hopefully. So Sam Nathans is asking, how does the pub-sub polling work on the Naryo to blockchain node RPC? What is the scale of API demand requests on the blockchain node itself? So so the pub and sub polling work, I would say, virtually like if I'm not mistaken, the product uses Web3j. Under the hood is a Java product, so it uses the native API as JSON RPC APIs that you will find in any like Ethereum. Talking about Ethereum networks, right? So it would just call the I don't know, ETH filter or ETH subscribe or all this method, and handle properly any connection issue that happen and all that stuff. You can, in terms of what's the scale of API demand requests on the blockchain node, if I get your question right, you're asking how many I don't know, events per second or something like that can Naryo handle, no? If that is the question, I remember a use case of an airdrop where probably would be like on the hundreds of events per second. You can configure Naryo to to poll, for example, you can configure to poll within the second. So to poll every, I don't know, 500 milliliters or something like that, if your DLT node or or your network supports that. So you really can, it's pretty flexible in that sense. So yeah, I hope that answers some, and happy to deep dive it more if needed. In any case, I will be happy to share. So it's a polling process, not pops up. So it if I'm not mistaken, essentially, okay. First of all, let me, so by those who are not seeing the chat, obviously Sam is saying that in a sense is polling, and that I have answered mostly their question. Sam, first of all, let me just share my email here in case you want to deep dive. And so yes, Naryo in a sense polls the node. I think I'm not 100% sure, to be honest, right now, if PubSub is right now supported in the Naryo project, right? But polling definitely, and Naryo, so it will poll the block for, not only a specific transaction, it will poll the block and, open the block, open the transactions, and then run the filters there, right? Okay. Oh, okay, sorry. Okay, so you mean it pops up with Naryo. So Naryo, I mean Naryo. So let me just share my screen quickly to go back on that thing. As an application, right? As an application, you don't ping Naryo, right? As an application, you receive a request. Perfect. So answer the question. You receive a request from Naryo. Yeah, exactly. We are building we have in the roadmap. Give me a second. We have in the roadmap a feature to actually. A second here. We have sorry, I was saying that we have a feature in the roadmap, which is querying the historical of events and stuff like that. And in that case, an application would call an API in Naryo. But right now, the main way to use Naryo is Naryo will like proactively, to say so, send the data somewhere else. So a queue, a database, an HTTP endpoint. This HTTP endpoint could be also the same backend that is that has configured Naryo. The configuration happens once, right? The configuration is not something that you do in real time or anything like that, right? Your smart contract events, the signature, for example, of your smart contract event are not changing in real time, right? You deploy the smart contract and that's it. You can reconfigure Naryo when there is a new version of your contract or something like that. Everything happens between step 2 and 3. Listening to events, sending events somewhere else in real time. Yeah. Let me see, because I'm talking a lot. I'm not seeing the chat. Okay, so that's the thing, Sam. In having Naryo rebroadcast LF NAT, so Linux Foundation NAT. So forgive my ignorance, but by LF NAT, what do you mean? Maybe I can rebrook. Okay, nats.io. Okay, let me just open a project that has been connected. Yeah, I mean, yes, I will happy to deep dive on that, Sam, if you want to drop an email or something. Sounds interesting, no? I was not familiar with NATS, but maybe it could be a fit, of course. Yeah, happy to learn more. I see there is a Slack channel here, so I will. Maybe you can reach out to me via email, or I can just join your Slack and get it from there. Okay, so Kafka Talmud is asking, does Naryo run as a container service? Yes. In fact, the demo, correct me, Mario, no? The demo that you were doing, what does use is a Docker container, and within that Docker container there is a backend. That backend is Naryo, right? So that, yes, you can run as a Docker. There is the documentation there for that. It plays the role like the proxy to pass the messages to different backend servers. In fact, exactly, yeah. It is an event listener, if we simplify Naryo is an event listener. And what it does is listening literally to events that are emitted in a blockchain and sending that to another backend. I'm sharing my screen, so let me go back here. That backend service could be an HTTP endpoint somewhere, so a backend, literally a backend with an API REST, where Naryo will send a request to broadcast or to pass through the event, or it could be a queue, RabbitMQ, Kafka, or a database. So all of that is okay. Perfect. Got it, Sam. Got your email. And yes, Kafka Talmud, I hope that answers your question. So yeah, that's pretty much it. It's a simple concept, to be honest. The hard thing is, making it resilient and handling high volume, multiple instances across different networks, etc. Right? Cool. Let me see. I have another slide here just in case. I won't deep dive here, but Naryo uses a modular architecture. So there is a module for the configuration API that you can extend. There is a module for processing everything that happened with the block processor. Nice to meet you. Sound perfect. I will drop you an email. There is a broadcaster that, again, you can extend. So the whole project is designed, this architecture, to be easily extendable and by the community, right? So that's why there is a lot of modules and stuff like that. Cool. So I will give Mario, feel free to jump in. I don't know if anyone else, because I know we have some developers of the actual developers of the project here. So if anyone wants to jump in, the floor is yours. The delivery metadata in this context. That's a great question. I will have to look at the documentation, Sam. But I can easily find it here. So what it will send. Well, Sam, I don't want to tell you something that is wrong. I prefer to send you an email with that. So what if I get it right? Your question is, what exactly does the recipient receives beyond the actual event data? No, what else is there? So metadata or timestamp, stuff like that, right? Oh, in the diagram is mentioned. I can see. Okay, so store delivery metadata. Yeah. Okay, so if I'm not mistaken, these are like traces exactly of timestamps, transaction hashes. If I'm not mistaken, also the node or kind of an identifier of a node that from which that event was received. Again, I will have to confirm, but that's the kind of data that goes there. So so that you can easily trace what is this event and where does it come from. Yeah, just mention optionally. Yeah, so what else? Any more questions? Cool. Hope guys it have been interesting. If no one else has anything else to say, to ask, we'd love to give you a few minutes back. Okay, so what type of Daniel is asking what type of virtual machine resources does Naryo take to run a production deployment? I mean, it's really a pretty lean deployment. I would say again, I don't know if this is documented or not. I can Daniel check our own deployments exactly and give you a specific number. But we are talking about a regular. I mean, I don't know, 8 gigabytes RAM, stuff like that. So nothing. I mean, pretty commodity hardware. So there is nothing really that big needed. The main resource that it consumes is bandwidth, because there is a lot of connection to the nodes, etc. Especially if you use a really little poll interval, and also there is a little bit of RAM, because and the second resource that it uses is RAM. Especially, for example, we have seen private Besu networks, which use we have really big smart contracts, complex events, stuff like that. So then the more complex the events and the data that is emitted, so more RAM it will use. However, it is again, it shouldn't be super big. Having said that, happy to give you a specific number if you give me an email or something. So Artur is asking, should I have webinar resources? Yes. So this webinar is being live streamed in YouTube. Artur, the link is here, and it is the other important link here is the project, right? And then I maybe can share the link to the Linux Foundation Decentralized Trust, which is a organization where the actual GitHub project belongs to the Linux Foundation Decentralized Trust. Oops. Sorry, I shared a specific link to the documentation file. Thank you, Mario, for sharing the specific.
No problem.
Yeah, Arthur, I hope that answers your question.
I share also the link into the YouTube chat. Yes.
Okay.
In case of anybody needs the link.
Perfect. And this is recorded, of course, by the way, so you can always go to that link and see, take a look later. Cool. You're welcome, Arthur. So yeah. So we still have like 10 minutes for a lot of more questions. If not, we can just call it a day, guys. So up to you. Well, let me stop sharing. So about the question of PubSub, just one of the developers, one of the main architect of the project, just told me in our chat that you can configure Naryo to listen to a node through WebSocket and polling through HTTP, and use PubSub, as you would use with any other standard connection to Ethereum JSON RPC API. So pretty standard stuff in that sense. So yeah, perfect. Happy that you liked the presentation, Daniel. Cool, guys. If there is no more question and comments, happy to give you a few minutes back. And again, happy to get your feedback and your contributions. Thank you very much for your attention. Bye, everyone. Okay. Now the live stream. Okay.